This next one is a piecewise function. They want us to sketch a graph of this function, explain why the function is not continuous at the a value of 0. And the reason they're picking 0 is, as you can see, our conditions here, that's where our piecewise function is switching. So let's get a graph here. So piecewise functions, remember, wherever that changeover point is, you want to graph only on that side. I'm actually going to do the bottom function first here. So the bottom function is the graph of x squared. We know that graph, whatever we put in, we square it. So if you put 0 in, you would get 0. If you put 1 in, you get 1. If you put 2 in, 2 squared is 4. There'd be a point there. And then there's symmetrical points on this other side. So the graph of that would look like that. But remember, piecewise, you're only graphing where the condition is. Here, the condition for that is only where it's greater than 0. So we don't want to include any points here where it'd be less than 0. So, right, only that part. E to the x, now you're putting whatever that in, the value in and doing it. So if you did e to the 0 power, that would be 1. So the point 0, 1 would be on this graph right here. If you did e to the negative 1 or e to the 1, e to the 1 is about 2 point something, so there's going to be a point about there. And then that's exponential growth, so it's going to be here. E to the negative 1 and negative 2, you're going to get some points that are diminishing towards 0 because we're going to get this exponential growth graph where it gets closer and closer but never actually touches 0 there. But again, we're looking at the condition. It's only where it's less than 0. So we don't want to include all this part of the graph to the right of the y-axis. And also, our point right at 0, there's no equals to sign with the top condition, so that should be a open circle there. All right, so it says a graph explain why this function is not continuous at 0. Well, you can see from the graph here, there's a jump discontinuity at x equals 0. And if you want to go with the definition of why this wouldn't be continuous, remember we need a limit here to exist. This limit is not going to exist because the limit as we approach 0 from the left of this function equals 1. The limit as we approach 0 from the right of this function would equal 0. Because here it's approaching 0, here it's approaching 1. Those are not equal, so it doesn't have a limit. If it doesn't have a limit, then you can't, that fails the definition of continuous, so they wouldn't be continuous.